In this video, we are going to solve the problem set number 1 to review for the midterm. So let's go over question 1. So find the limit if it exists. Okay. So a limit when x go to 2, x squared plus x minus 6 over x squared minus 4. Okay, so remember, when x go to 2 squared, 4 minus 4 is 0. You cannot divide by 0. So try to factor out this limit first before you can do the substitute. You can sub x equal to this fraction. So if you factor on the top, it's going to be x minus 2, x plus 3. Right, and then this is the difference of the square, x minus 2, x plus 2. This is gone, so only thing left is these two things. Now you can plug in 2 to this fraction. So 2 plus 3, 2 plus 2, that's going to be equal to 5 over 4. Very simple. The next one, limit when x go to 2, square root x plus 7 minus 3 over x minus 2. So now you plug in 2, the bottom becomes 0, which we don't want that. Remember, if we have the square root of something minus or plus with something, we should multiply by the conjugate of that. So let's multiply the top by the conjugate because the top has the square root. So if you multiply this by the conjugate, minus change it to plus. If you multiply the top, make sure you multiply the bottom as well. Now, remember, for the difference of the square, a squared minus b squared equal a minus b, a plus b. So we see here, something minus something, something plus something. So we have this format, which is a squared minus b squared, or this square minus this square. The square root of u square become x plus 7 minus 3 squared, which is 9, over the bottom x plus 7 plus 3. Now if you simplify it, you're gonna get 7 minus 9, which is minus 2, right? And the bottom, we rewrite this 7 plus 3. Now x minus 2 can cancel, right? That's what we want. And we have what? 1 over plus 7 plus 3. Now you can plug in 2 in, right? Because we don't have to divide by 0 anymore. So 2 plus 7 is 9. Square root of 9 gives you 3. 3 plus 3 is 6. That's all you have. The next one, C. Limit when x go to 2 plus of 1 minus x over x minus 2. Okay, if you plug in 2 on the top, 1 minus 2 is going to be minus 1, right? Or on the top you get negative value. Now on the bottom, 2 minus 2 is 0. But remember, this value is approaching 2, not exactly equal to 2. And we are approaching 2 from the plus side, or the right side of 2. So we can take the value of 2.01. So 2.01 minus 2 is 0.1, right? I mean, yeah. So if you take the value, for example, 2.1, right? For easy, 2.1. So 2.1 on the right side of 2, which is 2.1. 2.1 minus 2 is give you 0.1, for example. And 0.1 is positive value. So we have a negative over positive. So that will give us a negative value. And the negative infinity, because we are dividing something that's very close to 0. That's give you infinity. But we have to plug in a test point in order to see if it's negative and positive in order to determine for the side. Okay, so that is negative infinity for this problem. Part D. Limit when x go to infinity of 6x squared minus x4 minus 5 over 2x4 plus 3. Remember, when x go to infinity and we have the rational function, we have to divide the top and the bottom by the largest power of the bottom. So at the bottom, the largest degree of the power is x to the 4. So let's divide the top and the bottom by x to the 4. So 2x4 plus 3 divided by x4. Do the same thing to the top. x4 minus 5 divided by x4. This will give us what? This is going to be equal to 6 over x2 minus 1 over just 1, right? Because x4 and x4 cancel. Minus 1 and then minus 5 over x4. Bottom here, x4 and x4 cancel. Give you 3 plus 3 over x4. Now, when x go to infinity, this one go to 0, right? This one go to 0. This one go to 0. Because a number divided by infinity is 0. On the top, we have minus 2, 1. On the bottom, we have 2. So the answer is 2. Or minus 1/2. Okay, the next one, part E. The limit when x go to minus infinity, square root of 4x squared plus 3x plus 1 over x plus 5. Remember, on the top we have the radical, but we don't plus or minus with anything else. That's why we cannot multiply by the conjugate of that. But if x go to infinity or negative infinity, we can divide the top and the bottom by the largest power of the bottom of the fraction. Bottom of the fraction. Now take a look at the bottom. The largest power of this bottom or this bottom of fraction is x term, right? So we have to divide the top and the bottom by x. So let's do that. I divide the bottom by x. I divide the top by x as well. Plus 3x plus 1 divided by x. Now, the x now is outside the square root. Let's bring that to the inside of the square root, right? And that's one more thing to remember. Because the square root of x squared, if you bring this one to the inside, you have to square that in, because you bring that to the inside, it's become x squared, and when you take the square root, you get back to x, so we don't change anything. So if we can bring that to the inside, right? We can bring that to the inside. So 5x squared plus 3x plus 1. If you bring this to the inside, make sure you square it, because when you take this one back, you got x back. But now, if we take this one back, we got x. But remember, because x is going to the negative infinity, negative side, that means this value is negative. This x is negative. And if you take the square root of something, you got a negative number. That doesn't make sense. You have to include that another negative side, so that when x go to negative and you have a negative, that cancel out, give back you the positive value. When you take the square root of something, it should give you back a positive value. That's why in here, the x squared, when you bring that to inside, make sure you have a minus sign, because we have to include this minus sign in order for us to the minus side we put it outside, because if you take back the square root, you got x, which is x go to negative infinity, which is some negative number. Then we have a negative on the outside, which give back you to the positive value. Because when you take the square root of something, it must be a positive value. Now, the bottom parts, if we do that, x and x give you 1 plus 5 over x. And on the top, let's try to clear that. You have a negative side, that's why the reason we have negative side. So, x squared and x squared, that's gone. Plus 3 over x, plus 1 over x squared over 1 plus 5 over x. Now, when x go to a very huge negative number, this term is gone. This term is gone. This term is gone. On the top, we have negative square root of 4 and 1 at the bottom, which is minus 2. Okay, next question. Part F. Limit when x go to positive infinity of 1 over square root of x squared plus x minus x. Now we have radical and minus something. We know that we have to multiply by the conjugate of that. So multiply with changing minus to plus, right? So do the same thing to the top, x squared plus x, and then plus x. Now this one is a difference of the square, so I can simplify this this whole thing. A squared minus b squared, a minus b, a plus b, right? So this one square give me the one that without a square root, and minus of this one square for b. On the top we have what? X squared plus x plus x. Now x squared, this is gone, right? So all I have here is what? Square root of x squared plus x and plus x over x. Yes. Now I can factor out the x in order to cancel for this x here. So how do I do that? If I factor out, let's see. If I factor out the x squared here, I have what? I have 1 plus 1 over x, right? Because this gives you back x squared and this gives you back x, and plus x here. Now I can bring this one outside. Square root of x squared gives you back x. So we have x and square root of 1 plus 1 minus x plus x over x. Now you can factor out, oh sorry, this would be infinity, infinity, infinity. Okay, so you can factor out the x term, right? 1 plus 1 over x plus 1, and now we can cancel the top and the bottom, the x, and the rest is you just have, if x go to infinity, then okay, let's go to the next page. We have limit, the rest is x go to infinity, square root of 1 over 1 plus x and then plus 1. Now when x go to infinity, this term go to 0, right? 1 over x go to 0. So all we have left is square root of 1 and then plus 1, which is 2. Okay, part G. Limit when x go to 0. Arc tangent of x minus 1, 1 plus 2x. Now when x go to 0, let's plug in the whole thing. First, we have x minus 1, 0 minus 1, which is minus 1. 0 for here is gone, give you 1 at the bottom. So our tangent of minus 1. This is equal to tangent of something give you minus 1, right? That's what it means. So tangent of something give you minus 1, which is minus pi over 4. Tangent of minus pi over 4 give you minus 1. Okay, second question. You want to find the tangent equation of a tangent line. Okay, so find equation of tangent line to y equal x squared plus 2x as the point 1, 3. Remember, we need what? Y minus y0 equal m, x minus x0. So this is x0, this is y0, right? All we need is the slope m, and m is the f prime of x, or if we use the limit when h go to 0, it's going to be equal to 1 plus, x plus h minus f of x over h. Okay, but here we are trying to find the x at point 1, so we can plug in that 1 for x. So f x is 1 minus f of 1, this is minus, over h. Now f, we know that this is f of x, which is x squared plus 2x. So f of 1 plus h, you take the whole thing, you plug in for x, right, which is 1 plus h squared plus 2. Whenever you see x, you plug in this whole thing, 1 plus h minus f of 1. So 1 for x, 1 square plus 2 times 1, that's give you 3. So minus 3 over h. Don't forget the limit when h equal to 0. Okay, when h go to 0, now expand this out, try to factor out the h on the top to cancel the bottom parts. So 1 plus 2h plus h squared, you factor out that. Do the distribution here, 2 plus 2h minus 3 over h. That's going to give you, when h go to 0, 2h no, 2h and 2x give you 4h. Okay, 4h, and 2 plus 1 is 3 minus 3, so these are gone, and h squared over h. Okay, we can factor out the h term. So h, let's give you 4 plus h over h. H and h gone, right? So now we only have this 4 plus h remaining. When h go to 0, we have 4. So m equal 4. That's very easy. So now we have 4 for m. We have y naught, x naught. Just plug in y equal y naught is 3. M with 4, x minus x naught is 1. When you simplify that, you're gonna get y equal 4x minus 1. That is the line, the equation of the tangent line to the function y equal x squared plus 2x. Okay. The next one, number 3. This is similar stuff. So I'm given the function 1 over x plus 1. Okay, now I want to find f prime using the limit definition. Now the limit definition is what? Is the limit when h go to 0, f of h plus x minus f of x over h. Okay, so h plus x, you have f of x, so take this whole thing, plug into the place of x. So 1 over h plus x plus 1, right? So 1 over x, x now is h plus x, and then plus 1. That's for f of h plus x minus f of x, which is this guy, and then over h. Next step is you have to simplify that, right? So let me multiply by the common factor, common denominator for the top. I'll guess something h plus 1. This is the common denominator for the top. You guess x plus 1 minus h plus x plus 1, and on the bottom we still have h. Don't forget that. Now this is going to be equal to limit when h go to 0. On the top, we're gonna do the distribution of -1 to the inside. You're gonna get x plus 1 minus h minus x minus 1 over whatever you have on the bottom. Just keep it, and then remember over h. So x and x gone, 1 and -1 gone. We have minus x left, right? Minus x on the bottom, the top. Now the bottom is x plus h plus 1 and x plus 1. Now divide by h. This whole fraction divide by h. That means you can bring the h to here, right? Because multiplying by is reciprocal of that, and this h can be cancelled out. Let's give you a limit of h go to 0 minus 1 on the top, x plus h plus 1, x plus 1. Now when x go to 0, this gone, right? All you have left is minus 1 over x plus 1, x plus 1, which is what? Minus 1 over x plus 1 square. Very easy if you just apply directly the limit definition. Okay, next question. 4. I have this function x plus 6, x squared, and minus 4, and this is piecewise function. If x equal to 3. Okay. Evaluate the limit when h go to -2 on the top. Now we are looking for the left side of -2, which is this first function, something less than -2, right? Which is the left side of -2. So we are looking for this. So you have to plug in -2 to the first function and ignore the rest. So -2 plus 6 for x for -2 give you 4. The next one is when limit of x go to -2 on the right side. So the 2 of the right side is this guy, right? Bigger than -2. So we have to plug in -2 for x squared. That's give you 4. Now the limit when x go to 2, because the left side and the right -2, sorry, the left side and the right side equal to 4, right? We know that the limit has to be equal to 4 because the left and the right side limit are defined and they are equal. And the function of f equal -2, because then an equal sign here at -2, we have to use this function. So -2 squared give you 4. Okay, the next one is when limit of x go to 3 minus. This is the left side of -3, right? So 3 is here, the left side is less than 3, so we use this function. So we have 3 squared give you 9. The limit when x go to -3, but the right side have to use this one, which is -4 as always. So the limit when x go to -3, this one does not define or undefined. The reason because the left and the right side limit, they are not equal. And the value when f equals 3 equal right here. So 3 squared give you 9. Okay. The second part, they are asking, is f continuous as x equal -2? Okay. When x equal -2, we have the value equal 4 and the limit equal 4. So yes, because the value of x -2 and the limit, they are both equal to 4, f is continuous. Okay, what happened to 3? Because the limit is undefined, and even though we have the value for that function equal 9, but the limit is not defined, therefore f is not continuous, so no for C at the point x equal -3. Oops, let's. Okay, this next question, number 6. So they said that use the intermediate value theorem, or IVT, intermediate value theorem, to solve that the equation for x squared plus 1 equal 3 sine of pi x has a solution on the interval 0, 1, 2. So remember, for the intermediate value theorem, we have to show at a two endpoint that if one value is negative, the other value is positive, then the function must go to the middle, which is the 0. So that equation had the solution for the 0 or the root. Now we need to define that function first. So first, you want to make the equation equal to 0 on the right side. So I must bring the right side to the left side and make it become 0 first, and call that the function f, right? So for x squared plus 1 minus 3 sine pi x, if I bring that to the left side, I have 0. So this is the function f. Now I want to check the value at the two endpoint. So the first one, f of 0, give me 0 from 4 is 0, plus 1 is 1, minus 3, 0 for x, which is sine 0. That gives me 1, right? Because this is 0. The other endpoint is 1/2. So 1/2 square give you 1/4, and 4 divided by 4 give you 1. 1 plus 1 minus sine of pi over 2. Sine pi over 2 give me 1. 1 minus 1, that's gone. Give me oh, sorry, we have 3 here. Yes, I forgot to bring out the 3. So sine of 1/2 pi over 2 is 1. So we have 1 plus 1 minus 3 times 1 is 3. That gives me minus 1. So remember, from the intermediate value theorem, we have the solution for this equation because the function had the value at the two endpoint, minus and plus, negative and positive. So that's why it must go to the 0. So we can write f of x is a continuous function. The first thing is we need to say that this function is continuous, right? Because this is just polynomial and trig. They are all continuous. It's a continuous function on the closed interval of 0 to 1/2. F of 0 and f of 1/2 have the opposite side. So by the intermediate value theorem, there is a value c in the interval such that f of c equal to 0, or this whole thing equal to 0, or if we bring back here, we have this equation become true. Right, so that's the end of the set 1 review problem.